Have you ever really stopped to think about where the water in your glass comes from? I mean, its entire journey. Today, we're going to trace that path all the way back from your faucet to the farm. And believe me, it's a connection that impacts every single one of us in a huge way. So right off the bat, you might be thinking, what does a farm, maybe hundreds of miles away, have to do with my water? And that's a fair question. They can feel like two totally different worlds. But as you're about to see, they are deeply, deeply connected. To get it, we've got to zoom out and look at the bigger picture.
All right, let's dive into part one. To really understand this whole farm-to-faucet thing, we first need to get a handle on how water actually moves across the landscape. Think of this as, the basic plumbing of our planet.
And the key concept here is the watershed. Now here's the cool part. Every single one of us, no matter where you are, lives in a watershed. Just picture a giant bowl. Any rain that falls inside that bowl is going to drain down to the same single point at the bottom, whether that's a river, a lake, or the ocean. This is exactly why something that happens way up high on one side of the watershed can have massive ripple effects miles and miles downstream.
So where does agriculture fit into this puzzle? Well, it's the biggest example of what scientists call non-point source pollution. Okay, so what does that mean? Unlike, say, a single pipe from a factory, which is a point source, this kind of pollution doesn't come from one specific spot. It comes from all over, from broad areas of land carried by rainfall. And that, as you can imagine, makes it a whole lot trickier to manage.
Okay, so we've got the how water moves down. Now, for part two, let's look at the what. What exactly can that water pick up and carry with it from a farm field? This is what we call the off-site movement of agricultural pollutants.
We're mostly talking about these four characters right here. You've got nutrients, like nitrogen and phosphorus from fertilizers. You've got pesticides. Then there are pathogens, like bacteria from animal manure. And finally, you have sediment, which is just soil that's been washed away. All of these guys need a ride to get from the field into our water.
And these are their three main modes of transportation. Runoff is probably the easiest to picture. It's just water flowing over the surface, grabbing stuff as it goes. Leaching is a bit different. That's when water soaks down through the soil, dissolving pollutants and carrying them deeper, kind of like making coffee. And erosion? Well, that's when a soil itself moves, and any chemicals attached to those soil particles just hitch a ride.
Now the thing is, some of these pollutants are way more mobile than others. And nitrate, which is a form of nitrogen fertilizer, is the poster child for this. It is super soluble. It dissolves in water so easily, which means it can leach way down into the soil and, you guessed it, get into our groundwater. And for a lot of communities, groundwater is their primary source of drinking water.
So this brings us to the big so what question. What actually happens when these pollutants, especially all those extra nutrients, finally make it into our rivers and lakes? Well, it's not pretty. It kicks off this powerful and often really destructive chain reaction.
This whole process has a name: eutrophication. The simplest way to think of it is that we're basically over-fertilizing our water bodies. All those extra nutrients hit the water and boom, you get a massive, explosive growth of algae. But here's the twist. When all that algae eventually dies, the bacteria that show up to decompose it are incredibly hungry for oxygen. They use up almost all of it. So, now, eutrophication, it's not just about some slimy green water. The real danger is that hidden process of oxygen depletion happening underneath the surface. When those oxygen levels drop dangerously low, we call it hypoxia. And at this point, fish, crabs, you name it, they just can't breathe. This is exactly how we end up with what are famously called dead zones, huge areas of water where life just can't survive. And if things get really, really bad, you can reach a state of anoxia. That means zero dissolved oxygen, total absence. It's pretty much the end of the line for that aquatic ecosystem. But these consequences aren't just for the fish. When nitrates get into our drinking water, it's a direct threat to human health. In fact, the US EPA has set a strict limit for nitrate nitrogen, 10 milligrams per liter. Anything above that is considered unsafe to drink.
And this risk is especially serious for infants. High nitrate levels can lead to a dangerous condition called methemoglobinemia, often known as blue baby syndrome. It basically robs the blood of its ability to carry oxygen. It's incredibly serious.
And it isn't just a human problem. Take a look at this. High nitrate levels are also toxic to livestock, with pregnant animals being particularly at risk. It just goes to show you that managing water quality isn't just about the environment downstream. It's crucial for the health and success of the farm itself.
Okay, that was a lot of doom and gloom, I know. But here's the pivot.
The good news is that we have solutions, powerful ones. So now let's talk about the best management practices that can help us build healthier, cleaner, and more resilient watersheds for everybody.
I mean, just look at this comparison. It really lays out the two choices we have. On the left, that's where we're headed if we do nothing. But on the right, that's the goal, a thriving, healthy watershed. The solutions we're about to cover are all designed to get us from that left column over to the right.
And, sometimes it starts with the simplest things. A really basic but crucial step is just protecting the wellhead. The best practice is to make sure any area where you're mixing or loading fertilizers and pesticides is kept at least 50 meters away from a borehole. It's all about creating a simple safety buffer to prevent a direct line for contaminants into your groundwater.
Next up, filter and buffer strips. It's incredible how much work a simple strip of grass or trees along a stream can do. They act like a natural barricade. They slow the runoff water way down, forcing it to drop the sediment it's carrying. Then, the plants themselves actually suck up the dissolved nutrients. It's like a natural filtration system, and it works wonders.
Speaking of natural powerhouses, let's talk about wetlands. People often call wetlands the kidneys of the landscape, and it's a perfect analogy. They are absolute champs at filtering out pollutants, soaking up floodwaters like a sponge, and providing incredible habitat. Protecting our existing wetlands and restoring old ones is a massive win for water quality.
We can also get a little high-tech and use engineering to give nature a boost. This is a bioreactor. It sounds complex, but it's really just a trench filled with wood chips placed in a strategic spot to intercept field drainage. What happens is, there are special bacteria that love living on those wood chips, and they perform a little magic trick called denitrification. They literally convert the harmful nitrates in the water into harmless nitrogen gas, which just goes back into the air. Pretty cool, huh?
At the end of the day, there is no one magic bullet. The real solution is a combination of things. It's about using smart, targeted practices on the farm while also protecting and restoring the natural infrastructure, like buffer strips and wetlands, that's already designed to keep our water clean.
So the link between what we do on the land and the quality of our water is crystal clear. It leaves us with a final question to think about. Knowing all this, what can we, as individuals, as communities, do to better support the health of our very own local watershed? Thanks so much for tuning in.